Alright, welcome to Lesson 65. In Lesson 65, we're going to be talking about proportions with mixed numbers and also using proportions with similar triangles. So two kind of complicated topics, but I know you can get it. Let's look at example 65.1. We have some double fraction bars, and when you are writing these, I would recommend making the second or the main fraction bar much bigger, just so that's very clear. And then 2 1/5 over 1 3/4. So the first step is to copy down the equation. The second step is to change all of these to improper fractions. So let's rewrite it. 4/9 over x, that can stay the same, but on the right side we have 11 over 5 and 7 over 4. Okay, so we have our unknown right here, this x. And just like we've been doing in the past, if you cross multiply 4/9 times 7/4, that will be equal to 11/5 times x. So we can rewrite that. 4/9 times 7/4 equals 11/5 times x. Now let's go ahead and simplify the left side so we can get ready to solve for x. We would have 28 over 36 equals 11 over 5x. Remember, the goal is to get x by itself. We have this 11/5 in the way. Let's divide both sides by 11 over 5, and I'm going to have to move over a little bit. 28 over 36 divided by 11 over 5 would mean we're going to multiply by 5/11ths. And that will be equal to x. And if you multiply, simplify, you should get 35 over 99. So that will be the answer to that problem. It just means you need to stay very organized and know which step to do first. So first, change to improper fractions, then simplify any multiplications you can so that you can solve for x, get x by itself, and then simplify your answer. Now we're also going to talk about similar triangles. Just give me a second to draw this, and you can go ahead and study them on page 206. Mine may not be exactly correct. So we have 6, 4, and an 8, and then a 2, 3, and a 4. So how do we know that they're similar triangles? Well, we know they're similar because they have these tick marks. Notice that these angles here, like angle A, B, and C, A, B, and C, there are little tick marks. So see how this one has 3 tick marks? That means that it's the same degree. So maybe this is, I don't know, 37 degrees. Well, in this triangle, even though it's smaller, this angle is also 37 degrees. And let's say this one's 62 degrees. Well, this one, even though it's smaller, is also 62 degrees. So with this information, now that we know that these angles are all similar, that can help us solve for different sides. So let's say that this 3, let's say we didn't know about this 3, okay? But we knew that these sides were similar. So on our first triangle, the side opposite the 1 tick mark is a 6. And then the side opposite the 1 tick mark here is our unknown. So we'll call that x. Now let's choose another side, like this 3 tick mark side. The side opposite the 3 tick marks is a 4. The side here opposite the 3 tick marks is a 2. So how do we get these numbers? Well, we just looked at the sides that were opposite of these similar angles, because we know that in similar triangles there is a relationship between the sides opposite similar angles. So now it's very easy to simplify. We can just cross multiply. So 6 times 2 is going to be equal to 4x. 12 equals 4x. Divided by both sides by 4, and we get 3 equals x. So that's just an example of how if you know that all the angles in two triangles are the same, then their sides are also, the length of the sides are also going to be related. And if you know a pair, then you can use that to solve for an unknown side as well. Go ahead and study example 65.2 if that is a little confusing to you, and then really use practice C to help you nail down how to solve those kind of problems. All right, this has been lesson 65. Just stay very organized, and I'm sure it will come together. And let me know if you have any questions.